further. Okay. For the time being, I am starting with the topics and I will ask the question with the students. Okay, so be attentive. So first thing is we will start with the very basic thing. Okay. So when the talk about the probability come into picture, so when we talk about probability, so whenever a random experiment is done, okay, so everybody should be aware what is the meaning of random experiment. So random experiment means an experiment whose outcome cannot be predicted. Okay, simple meaning is outcome not be cannot be predicted. Example. So for example, when we toss a coin, we can't predict whether it will be head or whether it will be tail. Okay. When we roll a dice, we can't predict which number will be there, whether it will be 1, 2, 3, 4, 5, or 6. Okay. So any such kind of event, like when we buy a share, we don't know whether it will be go up or whether it will go down. Okay, this can't be predicted. So any such situation where we can't predict such situation, we can say it is a random experiment. Okay. Definitely, we can't predict the outcomes of random experiment. What is the final outcome that is going to be there? But we know what are the all possible outcomes. For example, when we toss a coin, we know either it will be head or it will be a tail. Or when we roll a dice, we know that it will be one of the number from 1 to 6. Okay. So when we write all these outcomes in a set, that set is called sample space. So second important thing we should know is what is the meaning of sample space. Okay. So sample space means set of all possible outcomes. So example, sample space we generally denote by capital S. And when we toss a coin, so two possibilities are there, head or tail. So when we write all these possibility in a set, this set is called sample space. Or let me give you more examples. So when we roll a dice, so 1, 2, 3, 4, 5, or 6, these are the outcomes. So this set is called sample space. When we toss two coins, so what are the possibilities? Either both the coins will be head. Okay. So students, you also participate. Okay, so that we can interact and we can make this class as interactive class. Okay. Uh, so you need to tell me what are the possibilities when we toss two coins. So for example, Mukul Sharma. When we toss two coins, what are the possibilities? You need to tell. Mukul Sharma. Okay, Ayush they. So yeah, I also want to know that the students who are in this class, they are the only repeat student, or is there any improvement student also? Okay. So if there is any improvement student, do tell me if somebody want to improve the grade so that I can design my lectures as per that. So is there any improvement student? Okay. Tanveer Hossain Pavel has shared a WhatsApp group link, I think. So I have I'm joining it. Okay, I will share the material. Okay. So is there any responsive student? I want to know, like you are going to participate or not? Uh, Anmol Gupta. Anmol Gupta, what are the possibilities when we toss 2 coins?
Sir, there are 4 possibilities.
Yes, right. So either we will get head on both the coins. What is the second possibility you can tell?
Sir, tail on both sides.
Tail on both the coins, right? So we denote by TT. TT means tail on both the coins.
Head tail and tail head.
Tail head and head tail. So these are the total 4 possibilities. Okay. So in the same way, like if I toss 3 coins, so in that case I will have either all 3 will be head. Okay. Either first is head, second is head, and third is tail, or first is head, then we have tail tail, or we have all 3 as tail, or tail tail head, or tail head head, or we have head tail head, or tail head tail. So how many we have? This total 8. Okay. So these are the total 8 possibilities. Now, are we going to write all the possibilities in this way? Okay. So is there any way to detect the total number of possible outcomes? Okay. So there is any very important principle that I'm going to explain here. How to count the total number of things. Okay. So for example, if I'm going to tell you about the principle of multiplication. Okay. Principle of multiplication. For example, when we are tossing 2 coins, I will first explain with an example. So when we are tossing 2 coins, okay, so every coin has 2 outcome possibles. On the first coin, either head or tail. On the second coin, either head or tail. Okay, and we are tossing both of these coins, right? So in this case, what we do to find the total number of outcomes, we just multiply this 2 and 2. 2 into 2 is 4. Okay. When we are tossing 3 coins, so coin 1, coin 2, coin 3. Again, in this case, what we have on the coin 1, there are 2 possibilities, head or tail. On the coin 2 also, there are 2 possibilities, head or tail. On the coin 3 also, there are 2 possibilities, head or tail. So total number of possibilities will be 8. Okay. So when we have to multiply the things, this I am going to explain. Okay. So there are 2 tasks. First task is T1 and other task is T2. The first task can be done in, let us say, m number of ways, and second task can be done in n number of ways. Okay. And if we have to do both the tasks T1 and T2, then total number of ways in which task can be done is m multiplied with n. For example, if I have 4 shirts and I have 5 pants, okay, then I want to wear 4 shirts as well as 5 pants, then total number of combinations that I can make out of these is 4 into 5, which is 20. Okay. So when we have 2 or 3 different kind of things and we want to do all these simultaneously, in that case, we multiply the things to find out the total number of ways, right? So is this principle of multiplication is clear? This we are going to use multiple times. Okay. So for example, if I am rolling 2 dice, okay. So the number of outcome which are possible in first dice is 6, and number of total number of outcome which are possible in second dice is 6. And if I roll these 2 dice simultaneously, the total number of outcomes will be 6 into 6, which is 36. So for example, what are those 36 outcomes? So either we can have 1 comma 1, means 1 on the first dice and 1 on the second dice, or we can have 1 comma 2, 1 on the first and 2 on the second, or we may have 1 on the first, third on the second. So in this way, 1 till 6, Then we have 2, 1, 2 on the first, and 2, 2, 2, 3, and so on. Okay, 2, 6. In this way, for 3 on the first dice and 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. Then 4, 1, 5, 1, 6, 1, 6, till 6, 6. So in this way, total how many outcomes are possible? 36. Okay. So we don't need to write all those outcomes. We can compute by using this principle of multiplication, because 6 possibilities on dice 1 and 6 possibilities on dice 2, and we have to roll both the dice simultaneously. So total number of outcomes will be 6 into 6, which is 36. So you guys are with me? Is there any doubt in the principle of multiplication?
No, sir.
Is this clear to all?
Yes, sir.
Okay.
Clear.
Okay. Now let us come to the first important point, or you can say what is the meaning of probability. Okay. So before coming to the probability, I have told you about a sample space. Okay. After sample space, I want to tell you about the meaning of event. What is the meaning of event? Okay. So event is any subset of samples. Any subset of sample space. Let me tell you with example. So for example, when you are rolling a dice and you want to get an even number. So even numbers are 2, 4, 6. This is subset of this 1, 2, 3, 4, 5 or 6. This is the sample space. This is the subset. So this subset is called event. Okay. Any subset we have, like we can have just getting the number 2 on the dice. Getting the number 2 on the dice, it is also an event. Okay. So let me call this as S, sample space as S. Okay. Now event we generally denote by the letter E. Event are denoted by E. Now we are going to learn about the main concept, which is the probability. Probability. So what is the meaning of probability? So suppose we want to know what are the chances, what are the chance of occurring of an event E. Okay, for example, when you want to know what is the chance of getting even number when you roll a dice. Okay, so what is the way to do it? So we see how many even numbers are there. 2, 4, 6. 3 even numbers are there. And then we see how many total numbers are there. The total numbers on the dice are 6. So it is 1 by 2. So what we are seeing here, we see number of favorable outcomes divided by total number of outcomes. Total number of outcomes. So favorable outcomes, what favorable means? The number of outcomes which are in the set E. For example, here 2, 4, 6. These are the 3 outcomes which are in the E. Okay. So it means number of elements in E divided by number of elements in sample space. Because total number of outcomes, how many total outcomes will be there? As many elements there are in the sample space S. Okay. Okay. So is there any doubt in the meaning of probability? How to find the probability?
No, sir.
Okay. Now I want to see some properties of this probability. Properties of probability. Okay. So first property is, if you see the probability of any event, this you are getting by dividing two numbers. Number of elements in E divided by total number of elements in a sample space. Okay. Now can number of element in a set can never be negative. Like I can't say that there are -1 number of elements in this set. Okay. Or there are -10 element in the set. Either there will be 0 element or there will be more than 0 element. So because probability of E we are getting by dividing two numbers which cannot be negative. So this probability is always greater than equal to 0. Probability is always greater than equal to 0. This is the first thing. Why probability is always greater than equal to 0? Because students, you can see here, let me highlight it. This n of E is number of elements in set E, and n of S is number of elements in a set. The number of elements in any set cannot be negative, right? So therefore, this probability P of E cannot be negative. It is always greater than equal to 0. Okay. Second property. So if you see the formula of probability of E, what we are doing? We are dividing number of elements in E divided by number of elements in S. And E is subset of S, right? So number of element in a subset is always less than equal to number of element in a set S. So when you divide a small number by a large number, the answer is always less than or equal to 1. So therefore, probability of any event is always less than equal to 1. This thing is clear, that probability is greater than equal to 0 and probability should be always less than equal to 1. These two things are clear. Why this is true?
Yes.
Because
Yes.
this cannot be negative. Number of element in a set cannot be negative. That is why it is always greater than equal to 0. Why it is less than 1? Because E is subset of S and number of element in a subset is always less than or equal to number of element in a set. Okay. Third property is, like if I ask you, there are 40% chance of rain today. Okay. And then I ask you, how many chances are there that there will be no rain today? Okay. So if I'm saying 40% chance are for the rain, then how many percent chance are for the no rain?
60%.
60%, right? So what is it? So this is just, I want to say here that if you want to find probability of complement of an event or probability of or not happening of an event, so you can simply do 1 minus probability of happening of the event. Okay. Let me, this is 1, right? Okay, this is 1. 1 minus probability of happening event. So for example, when I'm saying 40% chance, so 40% means 0.040, and then you answer that this is for happening of E, right? And sorry, this was for happening 40%, and then I ask you what is probability of not happening or probability of E complement. Then you told 60%. So what is the 60%? How we are getting the 60% means 1 minus 0.40. Okay, 1 minus 0.40, which is actually 0.60. Okay, so these are the three properties. These basic properties always keep in mind. Okay, because in some question, if you are getting probability less than 0, it means you are doing something wrong. In some question, you are getting probability greater than 1, it means there is something wrong. Okay, now let us come to the first important topic of unit 1. That is, what is the meaning of random variable? Meaning of random variable. Okay, the most important aspect, or you can say this is the most important thing we need to understand from unit 1. So till now, what we have done, we have studied about the random experiment. Random experiment means an experiment whose outcomes cannot be predicted. Then we studied about the sample space. Sample space means a set where we write all the possible outcomes, right? And then we studied what is the meaning of event and then how to find probability of an event. Okay. Now I'm going to talk about the random variable. So what is random variable? So simple word, if I have a sample space, let us call this this is a sample space when you toss 2 coins. These are the possibilities when we toss 2 coins, either both will head, one head, one tail, first tail, second head, or both are tail. now this is sample space, right? Now, if I give a number to every outcome of this sample space, so let us say I give this as a number 0, I give this as a number, let us say 1, I give this as a number 2, and I give this as a number 3. So what I have done, I am giving the numbers to every outcome of a sample space. This giving of numbers is called random variable. Random variable is a function which associate the numbers with outcomes. It can be any function. It can be any function. I'm repeating again. It can be any function which gives the number to every outcome of a sample space. So for example, instead of giving this number 0, 1, 2, 3, I could have also given this number as I could have also given this sample space as numbers, like I could have given this number 0, this also 0, this also 0, this also 0. This is also a random variable. Just giving the numbers to the outcome. Just giving a number to the outcome. So what is random variable? So a random variable is a function that associate students, everything is fine, means my screen is visible to you and you are able to clearly listen to me.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So a random variable is a function that associate a real number to a outcome, to every outcome of a sample space. Okay. So what is it basically? So random variable we generally denote by x, capital X or capital Y. So it is a function from sample space to real numbers. In simple words, it is a function from sample space to real number. Let me give you an example. So suppose this, when we toss 2 coins, head, tail, head, and tail. If I take as x is equal to number of heads. So what this x will do? So in this outcome, how many heads are there? I want to answer from you. In this first outcome, how many heads are there?
2.
2. In
Two
this
heads.
outcome, how many heads are there?
1.
Second, 1. In the third one,
1.
how many heads are there? 1. And in the fourth one, how many heads are there? 0. So you can see what this x have done. It has given the numbers to every outcome, right? So therefore, this x is a random variable. So this x is a random variable. Okay. This is one of the random variable. There can be so many. Okay, like I could have taken here x as number of tails also. That is also a random variable because this will also give the number to every outcome. In this case, if I take this x as tail, number of tails, then here we have 0 tail. Here we have 1 tail. Here we have 1 tail. Here we have 2 tails. So this is also giving the number to the outcome. So it means this is also a random variable, right? Random variable just means we have to give the number to every outcome. Okay. Now, why we are giving the numbers to the outcomes? Because numbers are easy to deal. Okay. And like in this example, so I'm taking number of x as number of heads. So it has a meaning also. Okay. So I can write the outcomes in some order depending on the number of heads here. And in some cases, it may be have some different meaning, like when I am picking 10 items from the manufactured items and I want to know how many defective items are there. I want to know the probability for different number of defective items. So if I take the X as number of defective items, so that will also give the numbers to every outcome, right? And that is also a random variable. So for example, if I have 5 balls, 5 red balls, and let us say two green balls. Okay. So if we randomly pick 2 balls out of this, okay. So then what are the possibilities? Either both will be red, or first red, second green, or first green, second red, or both will be uh, green, right? And if I take here X as number of green balls, okay. So how many green balls are in the first outcome? 0. How many are here in the second? 1. In the third one here, 2. It is same example as the number of heads, right? If I have 5 good items and 2 defective items, and I pick any 2 out of these 7 total. If I pick any 2 defective items, so what are the possibilities? Again, either both can be good items, or first defective, second good, or first good, second defective, or both are defective. If I take here X as number of defective items, so this is also a random variable. So here we have no defective, so it will give the number 0. Here we have 1 defective, here we have 1 defective, here we have 2 defective. So random variable just means giving the numbers to the outcomes. This much is clear? Or any doubt is there in the meaning of random variable? The meaning of random variable is clear to the students? Tanveer?
Clear, sir.
Okay. Okay. Now, what we are going to do? So what we are going to do next? Okay. So now, I will start with this example. Okay. So suppose two coins are tossed, right? And we have to find the probability for different number of heads. The example is random. First of all, random experiment is tossing 2 coins. Tossing 2 coins, right? And you have to find probabilities for different number of heads. Okay. So when we toss 2 coins, now multiple time I'm using this example for the explanation. So these are the possibilities: head, tail, tail, head, tail, tail. Now we have to find possibilities for different number of heads. So let us take X as number of heads. So what are the possible values of number of heads? Means what are the possible values of X? When we toss 2 coins, either there will be 0 head, either there will be 1 head, or there will be 2 heads, right? Now we have to find what are the chances of getting 0 head. So student, I need your cooperation here. What are the chance of getting 0 head when we toss 2 coins?
1/4.
1/4, because total number of possibilities are 4. 1, 2, 3, 4. 4 possibilities are total, and we need 0 head. So 0 head is only in this case when we are getting both as tail. Okay. So 1 is in the favor, total are 4. So probability of getting 0 head is 1/4. Now, what is probability of getting 1 head? What is the probability of getting 1 head? So again,
2/4.
total number of possibilities are 4, right? Yes. Some student is saying 2/4. So very good. So you can see in this we have 1 head, in this we have one head. So only 2 outcomes are such where we have one head. Total outcomes are 4. And in 2 we have one head. So therefore, probability of getting one head is 2 by 4. Okay. Now I will find what is the probability of getting 2 head. So again, total number of possibilities are 4. In how many of these outcomes we have 2 heads? So there is only one such outcomes. So you can see here, only this outcome. One outcome is there in which we have 2 heads. 1 by 4. Okay. Is this clear how I found the probabilities? Because from here I am going to explain the next concept from this example. Okay. So let us analyze this example. What we have done in this example. First of all, x was number of heads. So this x is a random variable, right? Because it gives values to every outcome. And what are those values? Either 0, 1 or 2. For every outcome, we have given some number. Either 0, 1 or 2. Now, for every number, like for number 0, for number 1 and for number 2, we have found probabilities. We have found probabilities for different possible numbers. Or I can say I have found the probabilities for these are the different values of random variable, different values of random variable. So when we find the probabilities for different values of random variable, this probability function, this P is called probability mass function. What this P is called? Probability mass function. So I am going to introduce very important concept here. The concept is what is meaning of probability mass function. In the exam, there will be questions from probability mass function. Okay. So when we say any function is a probability mass function, okay. So when we say a function is a probability mass function, so a function px is called probability mass function PMF or probability distribution function PDF if it satisfies these following 3 properties. So property number 1, the value of px should be always greater than equal to 0. Why this is so? So you can notice here, because p of x is telling us the probability, and probability is always greater than equal to 0. Probability is always greater than equal to 0. So that is why PA of x should always be greater than equal to 0. First property. Second property. Students, if you add these 3 probabilities, probability at 0, probability at 1, probability at 2, means 1 by 4 plus 1 by 4 plus 2 by 4. So what the answer you will get?
1.
1. And that is the second important property, that sum of all probabilities, sum of all the probabilities, that should be equal to 1, because total probability should be 1. One of the events should definitely happen. If we are doing some experiment, then one of the value must occur. Okay. So either 0 head should be occur, 1 head should be occur, either 2 head should be occur in this example, right? In the same way, whenever we do any kind of experiment, so one of the outcome must be there. So total probability should be 1. And third thing is what this px tells. So what this px is telling to us. So this tells us what are the chances that the random variable will have value x. For example, if you see this p0, so p0 is telling us what are the chances that x will have 0 value. If you see this P1 is telling us what are the chance that X will have one value. P2 is telling what are the chance that X will have two values. Okay. So a function Px is called probability mass function or probability distribution function if it satisfies these three properties. Probability is always greater than equal to 0. Sum of all probability should be 1. And third property is probability that, what does it tell us? It tells us what are the chances that random variable will have value X. So students, if anyone have doubt in the probability mass function, you can ask. So let me tell you the whole things in the summarize. Let me summarize all the things what we have done till now. Okay. So first of all, we have done a random experiment and we have written all the outcomes of that random experiment in a sample space. Then to different outcomes of the sample space, we have given the values using random variable. So random variable X. Okay. It gives the value to every outcome. So like it gives 0, 1, it may gives any value, any real number. Okay. So let us call those values as X. Now further, we have found probabilities. Probabilities for different values of. We have found what are the chances that random variable will have this value. And this we are calling as probability distribution. Probability distribution. Okay. Let us discuss more examples. Okay, of the probability distributions. So question is, for example, is suppose we have let us say 3 balls and let us do this one. We roll 2 dice. So random experiment is let us say find the probability distribution of find the probability distribution of sum of numbers on 2 dice when 2 dice are rolled. 2 dice are rolled. So what we have to find, students? We have to find the probability distribution. We have to find the probability distribution. Probability distribution, what does it mean? It means we have to find the probabilities. What we have to find? We have to find the probabilities for different values of X. So whenever they ask in a question, find the probability distribution, they also tell you whose probability distribution. So here they are telling probability distribution of sum of numbers, it should be numbers here, right? Sum of numbers on 2 dice. When 2 dice are rolled, so when 2 dice are rolled, so there will be one number on first dice, there will be, let us say, second number on other dice, and if you do sum of these numbers, so that they are calling as X. So first of all, what are the possible values of X? So what are the possible sums when we roll 2 dice? Let me ask. Saurabh Kumar. 1, 2, 3, 2, 4, 7, 7, 0. Saurabh Kumar. Saurabh, if you are present, you please respond. Okay. Komal Rana.
Yes, sir.
You need to tell me, like, when we roll two dice, right? And X is sum of the number on the dice. Okay, sum of numbers on two dice. Sum of numbers on two dice. So what are the possible values of X? What can be the possible sum? So any idea you have, you can share.
So like the values, we will get like 1, 1 or 1, 2, 1, 3.
Right. If you get 1, 1, in that case, sum will be 2, right? So the one possible
Yes.
value is 2. Other possible values. So can sum be
2.
1?
Yes, sir.
Sum cannot be 1 here because minimum numbers that we get on dice is 1, 1. So sum cannot be 1. So total sum, minimum sum is 2. Or it can be 3, right? It can be 4. It can be 5. Maximum it can be 12. When it will be 12, when you get 6 on the first dice and 6 on the second dice, right? So is this clear? The possible
Yes.
values of sum on the dice. Okay. And now we have to find the probability distribution. What is the meaning of probability distribution? Probability distribution means for these different values of the sum, or for these different values of the random variable, we need to find the probability. Like we need to find what are the chance of getting sum 2. So what are the chance of getting sum 2? So students, first of all, you need to tell me total number of possibilities when we roll two dice. How many total number of possibilities are there? So let me see who can tell me. So
36.
Kushal Kumar, can you answer this question? When we roll two dice, how many total outcomes are possible? So students, if you will participate in the class, it will be more interesting and more learning. Okay. Some students are participating, but others are not. 36. We shall have answered 36. Okay, good. Correct. Okay, total number of outcomes are 36 because there are 6 possibilities on the first dice and 6 possibilities on second dice. So principle of multiplication says total 36 outcomes are possible. I can write all those 36 outcome also, but there is no use of it. Like if you want to write, you can write 1, 1, 1, 2, 1, 3 till 1, 6. Then 2, 1, 2, 2, 2, 6, 3, 1, 3, 2 till 3, 6, and so on, right? So total number of outcomes are total 36. Out of these 36 outcomes, which outcomes will give you sum 2? So that you need to tell. Let us say, let me ask this. Aryan Mishra. Aryan? Aryan? आर्यन बेटा जवाब दो. Aryan, Akshay.
Sir, the probability will be 2 upon 36.
No, my question is,
Sir, the
sum
outcome
2.
1, sir, 1 and
हाँ
1 will be give
हाँ.
that.
So yes, this is one outcome which will give us sum 2. Is there any other outcome which will give sum 2?
No, sir, there won't be any other.
No. So there is only one outcome now, which will give sum 2, right? And total are 36, right? So therefore, probability of getting sum 2 is 1 by 36 because
Yes,
only one outcome is there, this 1,
yes.
1, which will give us sum 2. Okay. So now we will find what are the chance of getting sum as 3. What are the chance that sum of the numbers on the dice will be 3. So again, total number of outcome is 36. 36 possibilities are there total. Out of those 36 possibilities, which possibilities will give us sum 3?
Sir, 1 and
So,
2 and 2 and 1.
right, very good. Only two possibilities are there which will give us sum 3. That is 1, 2 and 2, 3. 2, 1. 1, 2 and 2, 1. So only these two will give us sum as 3. So right. So 2 are in the favor, total are 36. Now we will find in the same manner that what are the chance of getting sum as 4. So total there are 36 outcomes. Out of these outcomes, which outcomes will give us sum 4? Okay. So that you need to tell which outcomes will give us the sum 4. Student, please do participate. This class is
Sir,
for you, I think.
there will be 3 outcomes which will give this sum.
Sum
2,
4,
2,
right.
1, 3 and 3, 1.
2, 2, 1,
3
3, and
and 3,
3,
1.
right. Good. So these are the 3 outcomes which will give us sum 4. So you can see 2 plus 2, 4, 1 plus 3, 4, 3 plus 1, 4. So total 3 outcomes. In the same way, now we will find which outcomes will give us sum 5. So total outcomes are 36. Out of those 36 outcomes, so the outcomes which will give us sum 5 is, so you need to tell quickly, if you will tell fast so that we can do more questions. So Javed, Chaman, Ritik, you can tell.
Sir, 1, 4, 4, 1, 2,
1,
3, 3, 2.
4, 4, 1, 2, 3, 3, 2.
3,
So
2.
these are right. So is there any other? No. So these are the total 4 possibilities, right? So in this manner, we will find which outcomes will give us sum 6. Total there are 36 outcomes. Sum 6 will be given by 1, 5. Let me write here 1, 5, 5, 1, then 4, 2, 2, 4, and then 3, 3. I think these are the only. So 5 by 36. In the same way, we'll find which outcomes will give us sum 7. So 1, 6, 6, 1, 2, 5, 5, 2, 3, 4, 4, 3. So total there are 6 outcomes, right? Then we will find which outcomes will give us sum 8. The sum 8 will be given by 2, 6, 6, 2, 3, 5, 5, 4, 4. So there are, I think, 5, right? And then we, in the same manner, we will find which outcomes will give us sum 9. So these are like sum 9 means 3, 6, 6, 3, and 4, 5, 5, 4. So these are 4 outcomes. Then which outcomes will give us sum 10? So sum 10 means 4, 6, 6, 4, 5, 5. So 3, 5, 10. And then which outcomes will give us sum 11? So 6 and 5, 5 and 6. Is there any other? No. So 2 by 10. And which outcomes will give us sum 12? So there is only one outcome, 6 on the first die, 6 on the second die. So 36. I forgot to write this. I'm writing 10. I should write here 36. Total there are 36 outcomes. Okay. So students, what we are doing here. So you can notice here for different values of random variables, I am finding the probabilities. And this probabilities, this function which tells us the probability is called probability distribution. So that is what they asked to find us in the question. Find the probability distribution. Probability distribution simply means for different values of the random variable, we'll find the probabilities. Okay. Now, if you want to check whether your answer is correct or not, so what you can do, so you can add all these probabilities and you need to check whether sum is 1 or not. So let us add these probabilities now. So 1 plus 2, 3, 3 plus 3, 6, 6 and 4, 10, 10 and 5, 15, 15 and 6, 21, 21 and 5, 26, 26 and 4, 30, 30 and 3, 33, 33 and 2, 35, 35 and 1, 36. 36 by 36 is 1. So sum of all probabilities is also 1. Okay. So I am repeating again, what is the meaning of probability distribution? So this probability distribution is also written in this way, using this kind of table is made. Okay. So where on one side of the table we write the values of x. So in this case, the possible values was 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And second side, we write the probability of x or p of x. Sometimes small px is used to denote the probability distribution function or probability mass function. Okay. So here I will write the probabilities for different values of x. Probability of 2 getting 2 was 1 by 36. Probability of getting 3 was 2 by 36. Then 3 by 36, 4 by 36, 5 by 36. Probability of getting 7. 6 by 36. Getting 8. I think it was 5 by 36. 4 by 36. 3 by 36. 2 by 36. And 1 by 36. Students, you will see this kind of table in some questions. So this table is called probability distribution table or probability distribution. Okay. So a simple thing is that the sum of all probability should be 1. So is this clear to all students? Is this clear? These two
Yes.
examples which I have given. So these are clear. Okay. So there will be now I am going to tell or give an example of MCQ question which is asked multiple times. Okay, in the exams. So the exam, so this example is of this type, like, let me first ask you a basic question. Okay. So question is following is a probability distribution. You are given some probability distribution. So here you will be given x values and here you will be given the probability of x. Okay, so in some questions this px may be written as fx also. So keep in mind that. So for example, let us say it have value 0, 1, 2 and 3. Let us say, okay. And the probabilities we are given is 0.1, 0.2, and this number is not given. And this number 3, let us call it as, let me call this as 0.4. Okay. This is probability distribution. Following is the probability distribution given in the question. And you are asked find the value of k. Find the value of k. So students, I need the answer from you. So this is a very easy question.
0.3.
So 0. Then we have 3. 0.3. Okay. Nikhil Kaushal. Nikhil, answer this question? Okay, Ritik, Anmol Gupta.
Yes, sir.
Ritik, beta, you have to tell here this what is the logic for this question? Some student have given the answer, but how you will solve? What is your approach? Yeah, if you are
Sir,
listening to me,
PM is sir, probability mass function is always one. So simply we will calculate and minus it from the one, and we will get the value of k.
good, very good, very good. Good answer. So sum of all probability should be 1. This is the second property of probability distribution function. It means if I add this 0.1, 0.2, k and 0.4, the sum should be 1. So you can see here, this is the second property. Sum of all probability should be 1. Okay. So now if you add this, you will get here 0.7 plus k is equal to 1. So k is equal to 0.7. Okay. Now I will ask one more similar question, one or two similar questions because these are
K
asked in
will be
MCQ.
0.3 there.
So 0.3, 1 minus 0.7, that is 0.3. Good. Let me correct it. So k is equal to 1 minus 0.7, which is 0.3. So there will be multiple questions which will be asked from in MCQ. There will be one or two questions. Like one is from this discrete, other will be from continuous. So first I am doing the discrete kind of thing. So one more question I'm putting here, and I will ask this question to you. Just 1 minute. So I'm so So student, first we have to work on this kind of basics so that we can move to the 10 marks problems. Okay. So this random variable and probability distribution must be clear. Okay. Second question I'm going to ask is this one. So this is from the book. Let me share with you my screen on the other side. I want to screen share other window. So students, are you able to see this question? A random variable x has the following probability distribution. Okay. I actually want to take the screenshot of this, but I am not able to do it. I want to put it here. So is it visible, this problem?
Yes, yes, it is visible.
Okay. So same logic we have to apply here. Okay. We are given the random variable x and its probability distribution, and we need to find the value of k. Okay. So same logic will be applicable. Sum of all probabilities should be 1. Okay, sum of all probabilities should be. So first you try and you tell me the answer. Then I will solve it. So I will wait till 7, 8, 7, and let us see who can answer me this question.
Or 1 by 10.
1 by 10. Good. So good. Very good. Okay, now I will solve this question. So we know that sum of all probabilities should be 1. So what are the probabilities in this case? So 0 plus k plus 2k plus 2k. So k plus 2k plus 2k plus 3k. 2k plus 2k plus 2k plus 3k. Can somebody tell me, because I have to change the tab which is creating problem.
Sir, 3k plus k square,
3k plus k square
2k square
plus 2k square
plus
plus
7k
7k
square plus
square
k.
plus k equal to 1. Because sum of all probabilities is 1. So just adding all the probabilities, keeping it equal to 1. Now let us see what it becomes. So first of all, I will see how many k square I have total. So k square plus 2k square plus 7k square total. So 10k square. Now how many k's we have? 1 and 2, 3 and 2, 5 and 3, 8. 8 and 1, 9. 9k. And if I bring this 1 on this side, it will become a quadratic equation. So students, if you get the quadratic equation, so there are two options that you have. One is sometime it is possible to make the factor, and otherwise, if you don't know how to make the factors, then you can use this formula minus b plus minus under root b square minus 4ac divided by 2a. Okay, so if you don't know the how to make the factor, and directly you can use this one. Okay, otherwise first you can try to make the factor here. For example, I will see here that I have 10 here, I have 1 here. So on multiplication we should get 10, and on subtraction we should get 9. So what are such numbers? So 10 into 1. 10 into 1 is 10, and 10 minus 1 is 9. So we can write this as 10k square plus 10k minus k minus 1 equal to 0. If you take 10k common here, so you will get k plus 1, and if you take minus 1 common here, you will get k plus 1 equal to 0. So k plus 1 is common, and 10k minus 1 equal to 0. So we get k is equal to minus 1 and 1 by 10. But if you see k is equal to minus 1, this is not possible. So who can answer why k is equal to minus 1 is not possible? Why k cannot be minus 1?
Probability cannot be negative.
Probability cannot be negative, right? Because you can see the distribution table there, the probability was k, right? So probability cannot be negative, so minus 1 is not possible. So this 1 by 10 is correct answer. Good. Okay. So I have more questions of this type. Okay. So I have created a total of, you can see in the unit 1, total 30, 46 question I have created from the unit 1 MCQ questions. Okay. Today I will share in the group. Okay. And I want 1 to 9 at least. All of you should try. Okay. So in that I will ask. Okay. Let us move ahead. Let us move ahead now. So students, we have learned that what is a sample space, right? Now consider this random experiment. Random experiment is we have to toss the coin until we get head. Toss the coin until we get head. Okay. So what are the possibilities? Means what will be the sample space in this case? So either it can happen that we get head first time itself. If we get head first time, we have to stop. Okay. Or second possibility is like first time we get the tail, but second time we get head. If second time we get head, we have to stop. But it may also happen that first time we get tail, second time we also get tail, and then third time we get head. Then we have to stop. But it can also happen again that first time is also head, second time is also head, third time is also head. Now we have to do it toss again because we toss until we get head. It may happen that fourth time head occurs. And this will continue so on. So how many possibilities are there in this case? The total number of possibilities is infinite, right? So what is my point here? The point is in a sample space, there can be infinitely many outcomes also. Infinitely many outcomes also. But the good news here in this case was I can make the list of those outcomes. Whether these are infinite, for example, I can tell you what is the 10th element of this list. What is the 10th number element of this list? So that will be 9 times tails and 10th time head. If somebody asks me what is the 1 crore term in this list, so I can say him that at 1 crore place there will be head and rest of the place there will be tail. If somebody asks me what is the 100th element of this list, I can tell that 99 time tail and 100th time head. So if you can do this, if your sample space is finite or it is infinite, but listing is possible. Listing or making list is possible. Then we say such sample space is a discrete sample space. So such sample space is called discrete sample space. So discrete means either it is finite or it is infinite, but you can make the list. So for example, till all the example we have done till now, so all you have the finite number of outcomes. Okay. In all the examples that we have done till now, like when we are tossing 2 coins, when we are rolling 2 dice, when we are rolling 1 dice, right? In all these we have finite number of outcomes. So that is why this was a discrete sample space. Okay. And this example, when I have told you that toss the coin until we get head. In this example, we have infinite number of outcomes. but we can make the list of them. This thing is possible. So that is why this is also a discrete sample space. This is an example of discrete. Okay. Now, if I ask you that pick one number between 0 and 1, pick any number between 0 and 1. So what is random experiment here? You have to pick any number. The random experiment is pick any number between 0 and 1. Now what are the possibilities? Can somebody try to make the list of those possibilities? Can you make the list? And in this list, I should be able to tell you, like if I ask you what is the 100th number, then you should be able to answer. Is there any way of arranging all the numbers between 0 and 1 in a list? So it has been proved mathematically that this is not possible. The reason is, like, you can't tell what number will be next to 0. What number will be next to 0? You can't tell this. So you can't make a list kind of thing. Like you can't tell this will be the first number in the list, this will be the second number in the list, this will be the third. You cannot cover all the numbers in a list between 0 and 1. So this, the sample space of this will be infinite and you can't make the list. Such sample space is called continuous sample space. So what is the continuous sample space? Where making list is not possible. Infinite and making list is not possible. So whenever we talk about time, what, like for example, what are the possible times at which the student will enter in the class? So if I'm talking about the 7 p.m. class, so some student may exactly enter the class at 7 p.m. right? Some may enter the class at 7.000001 p.m. Some may enter the class at 7.00000002 p.m. So what are the possible times? We can't make the list. We can't make the list of all such times. Okay. If I ask you what are the possible length of, let us say, a wire, okay, so we can't make the list. It can be anything, like it can be 10 meters, it can be 10.5 meters, it can be 10.4 meters. So whenever we talk about time, whenever we talk about the length, whenever we talk about height, whenever we talk about time, length, height, weight, okay, these kind of things fall under the continuous thing. These are continuous things. These are not discrete, these are continuous things. Now, in case of discrete things, because we can make the list, okay, so it was possible to find the probabilities for different points. Like for example, you have seen here, we are finding probability of 0, probability of 1, probability of 2, probability of 3. Here we are finding probability of 2, 3, 4, 5 up to 12. Okay. So in the previous example, you are finding the probability for 0, 1, 2. So that is why we have defined this probability mass function, because it was possible to find the probability at different points in case of discrete. But in case of continuous, there are so many points you can't even make the list. So it is never possible to find the probability at a single point. Okay. Okay. So first I have not told you the random variables. Random variables are of two types. One is discrete and other is continuous. Okay. Discrete random variable means where the values taken by the random variables are either finite or you can make the list. Continuous means you can't make the list. Okay. So in case of discrete, we have the concept of probability mass function. Probability mass function. Okay. This is also known as probability distribution. Probability distribution. Short form is PMF or PDF. In the same manner, for the continuous case also, we have the concept of probability function. But in case of continuous, we can't find the probability at a single point because there are so many points. So what we do here, instead of finding the probability at a single point, we find the probability between the intervals. So for example, I am interested in knowing what are the chances that height of a student will be between 150 centimeter to 160 centimeters. Or what are the chances that a particular student will enter on the class during the time between let us say 6:55 p.m. to 7:55 p.m. So in case of continuous, we always find probability for the interval. In case of discrete, we find the probability at a point. Every point we find the probability. But in case of continuous, we don't find the probability at a point. We find the probability in the interval. Okay. So for the continuous, we have the concept of probability density function. Density function, or you can say probability distribution function. So distribution function, this name is in both the cases discrete and continuous, meaning is different for continuous, meaning is different for the discrete. Okay. So what is the meaning of probability density function? When we say a function fx is called a probability density function or probability distribution function if it satisfies three conditions again, same condition, similar type of condition. The first condition is
Excuse me, sir. Sir, your voice is
yes,
breaking. You are not
breaking.
clearly audible. It's breaking, sir.
Just 1 minute. Let me confirm from other students also. Ritik, Anmol, Tanveer, is my voice breaking on your side also, or is it only for issue for one student?
Yes, sir, your voice is cracking in between.
But now it's a little bit better than before.
Okay, it is now better. Just 1 minute. So from how much time the problem was there?
Sir, when you were just
So-
defining this, the interval thing, in continuous, we measure the intervals to get the probability.
okay. Till earlier it was clear, na? Means do inform me, students. For informing, do inform me if there is some issue. Okay.
Now it's good, sir.
Uh,
Now we could hear you properly.
okay. Thank you. So now we are learning about the top probability mass function, probability distribution for discrete random variables. Random variables are of types. One is discrete, other is continuous. Okay. So in case of discrete, we have concept of probability mass function. X when X is the mass function. Only was P greater than equal to 0. And third was, what does it tell? It tells the probability. In the same manner, in a variable, we have the probability density function. A function is probability density function if it satisfies these three properties. Property number one, the value function should always be greater than or equal to 0. This first property is same as the probability mass function. Second property is, if you remember, in case of discrete, sum of all probability should be 1. Sum of all probability should be 1 in case of discrete. In case of discrete, because we can make the list of points, that is why it was possible to do the sum of probability. But in case continuous, in place of summation, we have to do the integration. And total integration for all possible values, whatever values are there for the function, total integral should be equal to 1. The second property is same. This tells us the total probability should be 1. Okay. In place of summation, now we have here integration. And third property is, if you want to find what are the chances that the random variable will lie between two points A and B. What are the chances that height of a student will be between 150 centimeter to 170 centimeter? And if you find, how you can find? You can find by doing the integration from where to where? A to B of what? Of the density function. So let us relate the third property with the discrete case. So suppose there is a random variable that can take the value 1, 2, 3 and 4. And if I ask you, what are the chances that random variable can take value between 2 to 4? How you will find? So what you will do there in case of discrete, I am telling. So you will see what are the chances that x will be 2, what are the chances that x will be 3, plus what are the chances that x will be 4. Right? This you will do. So what you are doing here? You are doing sum from where to where? 2 to 4. Or what? Or probability distribution function. In case of discrete, this is for discrete. This one. So in discrete, if you want to find the probability from 2 to 4, what you are doing? You are in continuous. And what are the chances that x will take the value between 2 to 4? In case of continuous, you will do the integration from 2 to 4 of the probability density function. This is the analog. I am trying to relate discrete and continuous here. So is this clear? Student, is this clear? Probability density function. 3 properties. If any function satisfies these 3 properties, then such function we will call probability density function. And if some function is probability density function, that function must satisfy these 3 properties. Okay, let me give you an example, then it will be more clear to you. Okay. So example is simple.
Excuse me, sir.
Yes.
Sir, you are not audible clearly.
Ritik Singh is saying I'm not audible clearly.
Yes, sir. In middle, your voice is just being on mute, and then again it was audible.
Let me try if my voice is clear or not.
It's
Problem.
frequently breaking in between, so might be the internet connection is weak.
Okay. Actually, I'm connected to Wi-Fi. So other students also, please do tell me that is this problem is coming out on your side also or not. Aryan, Saurabh, Komal, is this problem on your side also? My voice is breaking. Students
Yes, sir.
are.
Yes, sir.
This-
Voice is breaking.
Yes, sir, your voice is breaking sometimes.
Okay. Okay, my internet signal is also showing this little bit weak. Okay. Let me see. My Wi-Fi connected. I'm trying to make the arrangement. Okay, so I think Wi-Fi connection is a little bit slow, I guess. Signal is
Sir,
also showing.
if you're using
Sorry?
headphones, then try to reconnect it. Like,
No, it is not. I think due to headphone. This is due to I think weak connection. I guess
okay, sir.
because in the signal strength also it is showing weak signal.
Okay, sir.
Like full strength is not there. Okay, so I am trying to change my place. Okay, then it may be better. Okay.
Yes, sir.
Webcam desktop sharing is on. Give me just 2 minutes, please. Okay, I want to make sure that.
Sure, sir. The screen is visible now, sir. But there is only 40 seconds left in the meeting. Sir, only the screen is visible. Your voice is not audible for us now.